Hi, my name is Brianna Mick. I go to Highland High School in Alt, Colorado, and today I'll be talking about fractals and fractal dimension. A fractal is an infinitely repeating pattern which is shown when an image is zoomed in or out on. But what exactly does that mean? One example of a fractal is the Mandelbrot set. It shows insane shapes and patterns when it's zoomed in on, and colors added to make it more interesting. Fractals can even be found in nature. One example is the fern. If you look at the overall shape of the leaf, it is similar to one of the leaflets that's on it, and then inside those leaflets are even smaller leaves that are also the same shape. Other fractals that are found in nature include lightning, trees, rivers which separate, snowflakes, lungs, blood vessels, and so much more. They're really everywhere. You just have to look. Another fractal that's found in nature is broccoli. I never looked closely at it until I realized that it was a fractal. But if you look, the main bump has smaller bumps on it that are the exact same shape as the larger bump. This is the Sierpinski triangle, or Sierpinski gasket. We will be finding its fractal dimension. But before we find that fractal dimension, we're going to look at some other shapes and use the scaling dimension relationship, which says copies equals scale to the power of dimension. For example, here's a line. It's one-dimensional. To quadruple its size, we would need to scale it by a factor of 4. So the equation would read 4 copies equals 2 scale to the second dimension. Now, for the second dimension, here's a square. To scale it by a factor of 2, we would need 4 copies, so the equation would read 4 copies equals 2 scale to the power of the second dimension. And 2 times 2 equals 4. Now, for the Sierpinski triangle. This one's a little bit more complicated. As you can see, there are 3 of the smaller triangles within the larger triangle. Doubling this in size would mean we would need 3 copies. So the equation would read 3 copies equals 2 scale to the power of what? Now to find d. We will work this equation with logarithms, which means we'll pull the d down so that it reads d equals log 3 over log 2. An easier way to remember this is log copies is above log scale. After plugging this into a calculator, we get 1.584. This has been only a short introduction into the world of fractals and fractal dimension. Thank you for watching.